Hi, my name is Meikun Yei, and I'll be presenting OLED, Organic Light Emitting Diode. First, we're gonna go through a very quick introduction, then the OLED structure, how it works, the different types of OLED, advantages and drawbacks, and then we'll finish with a conclusion. First, what is OLED? OLED stands for Organic Light Emitting Diode. It's a light-emitting diode in which electroluminescent layer is a thin film of organic compounds. It emits light with a current applied to it. We use OLED to make displays and lightings. Compared to LCD displays, there's no use of backlight. For a very quick history, in 1950 in Nancy University in France, is there where the first observation of electroluminescence in organic materials was found. And from that point, then research were made to do a device. And then in 1987, the first OLED device was finally invented by Eastman Kodak Company by two chemists, Ching W. Tang and Steven Van Slyke. And nowadays, OLED are widely used. They're used in smartphone and TV. And we all know that companies like LG and Samsung use them a lot. The OLED structure. So the composition of OLED is a cathode, anode, emissive layer, conductive layer, and substrate. As you can see on that picture, the substrate is right next to the anode. And then between the anode and the cathode, we have the emissive layer and the conductive layer. The cathode could be transparent or not. It injects electron when a current flows through the device. Anode or transparent. It adds electron holes when a current flows through the device. The organic semiconductor layer are the conducting and emissive layers. They are made of organic molecules or polymers. The conductor layers transport holes from the anode. The emissive layer is also made with organic molecule, but then it has to be different from the conductive layer. It transports electrons from cathode. Light is created in this layer. Then we have the substrate. It could be a clear plastic, glass, foil, or really anything that we want it to be. And it is used to hold the OLED. It's a support for the OLED. So OLED could have more than two layers of organic semiconductor. For example, we could have red emitting layer, blue emitting layers, and green emitting layers that are stacked together for greater resolution. How it works? So we apply a current across electrodes, and this injects electrons from the cathode, and the anode injects holes. Injects holes from the anode. Electrons and hole meets in the emissive layer. So, and then the electron and the holes combine in the emissive layer to form photons, and this photon is emitted in form of light through the anode and the substrate. That's why it's better to have a substrate that's transparent and as well as an anode that's transparent. As you can see on the picture here, the electroluminescence layer is actually the emissive layer, and so that's where the photon is made by an electron and a hole that are colliding together. So there's different types of OLED, such as the AMOLED, which is the active matrix OLED. So as you can see, there's a full layer of cathode and anode that's covering the whole device. We use also a thin film transistor array and storage capacitor to address each pixel. And so when you want to turn on a pixel and let the other ones around it to be turned off, then it will be possible thanks to the TFT matrix. It will be easier to address the pixel. We have also the PMOLED. The PMOLED is a passive matrix OLED. Compared to the AMOLED, the PMOLED has like anode and cathode that are perpendicular to each other, and each intersection forms a pixel. Compared to the AMOLED, it is limited in size and resolution. However, it is cheaper and easier to make than AMOLED. There's also transparent OLED, top emitting OLED, foldable OLED, white OLED, and all those depends on the substrate that you're using and also the layers that you're going to use. Like for example, white OLED is the red, blue, and green emissive layer together, stacked together to create a white light. And transparent OLED, just like a transparent substrate. So there is advantages and drawbacks. So some advantages of using OLED compared to LCD is that OLEDs have lower power consumption. It has a faster refresh rate and better contrast. Also a better contrast due to the pixel being off while the other ones are turned on. So it creates it creates a better contrast between on and off pixel. So the off pixels are really completely turned off compared to the one that's on, and that's due to the TFT matrix, or also the cathode and anode are being perpendicular to each other. And then there's a greater brightness, a better durability, lighter weight, but also new display opportunities. And some examples of display opportunities are in this slide, in these pictures. It could be very thin TVs like the LG TV here. So OLED allows companies to create very thin screens, but also bendable screens. And some also in China, they did the concept of a transparent cell phone, a transparent smartphone. So right here, they made it possible thanks to the OLED. There is some drawbacks to OLED. First, it is still expensive because it's very new. But then in the future, it has a lot of potential to be cheaper than LCDs. It has a limited lifetime, but then once again, it's getting better and better, and it used to be way better than in the past because now we can't even use them for our phone screen life. There's a problem still in the direct sunlight due to its emissive nature, but then once again, it's still in progress, and some companies, some scientists are researching it. So how can we make it better? How can its lifetime can be longer during even in the sunlight? So to conclude, those semiconductors are made of thin organic films, and by applying currents to the anode by applying currents and cathode and anode to inject electrons and holes, and those electrons and holes meet in the emission layer to form photons and emit lights. There's different type of OLED, such as AMOLED and PMOLED, and each has the different properties, and each of those properties can be used for what kind of device you want to make. It has its advantages and drawbacks, but researchers make it more and more advantageous than a compromise. Here are my references. So you're welcome to go look at those websites and see for yourself if there are more information you want to know about. And particularly this YouTube video on my references was very helpful for me to understand how it is used, how OLED are used, and how it works. So thank you for your time and have a good day. Bye.